Hello students, hope you are all doing well. During this COVID-19 pandemic situation, stay home and stay safe. Let's start today's session. Students, do you know that quantity surveyors are in great demand all over the world and we are next to the booming software industry. So I suggest all of you to have strong concept of fundamentals. In today's lecture video, we shall discuss about the detailed estimate and methodology of preparation of RCC Slab Culvert. I am Soumya Sahu, lecturer in Civil Engineering at SKDV Government Polytechnic, Rourkela, and this video lecture is prepared for the 5th semester Diploma Civil Engineering students. Okay, so let's start. Before going to the detailed estimate of RCC Slab Culvert, first I would like to discuss the definition of culvert. Culvert is a structure which is constructed to convey the surface water across a roadway or railroad. In addition to the hydraulic function, the culvert has to carry the traffic load. So while designing a culvert, a designer has to consider the hydraulic design as well as the structural design. And culverts are available in a variety of shapes, size and material. Different types of culvert. Here you can see box shaped culvert and pike culvert, arch culvert, rectangular culvert. Here again a picture showing box culvert, and here a picture of slab culvert. Okay, and in this slide I have shared the three-dimensional view of RCC slab culvert. See, it is the waterway. Here it is the waterway, and over here this is the roadway, this is the abutment, and this is called wing wall. This is the wing wall, and this is abutment. This is waterway, and this is the roadway. This is parapet. This is called the coping. So these are the different parts of a culvert. It is previously asked in the examination that what are the differences between an abutment and a pier. So students, abutments are end supports of bridge superstructure, and the main function of abutment is to retain the earth pressure of embankment, and it provides a final formation level to the bridge superstructure, and it also carries the weight of the superstructure to the subsoil, while piers are intermediate supports of multi-span superstructure in a water body, and the main function of a pier is to transfer the load of the superstructure to the subsoil. Piers are of two types. One is solid pier and another one is open pier. And abutments are also of two varieties. One is abutment with wing walls and another category is abutment without wing walls. You might be having curiosity that what is the difference between a bridge and a culvert? So definitely there are some differences. Culvert is made for passage of water, while bridge is constructed to allow the passage of traffic. Okay, bridge is constructed for the ease of passage of traffic, and the length of the culvert is 6 meter or less than 6 meter, while the length of the bridge is always greater than 6 meter. And bridge is constructed over a depression or obstruction, while culverts are constructed across small streams or small canals. So students, now we shall discuss the three-dimensional construction sequence of RCC slab culvert. Okay, so first look at this plan. This is the picture of a foundation, and you can see a channel shaped foundation. This is a channel shaped foundation, and it is showing an abutment. Here this is showing an abutment, and wing wall. This is the bottom view of the foundation. Okay, so thus you can see two number of abutments. Here it is number 1 abutment, it is number 2 abutment, and 4 numbers of wing wall. 1, 2, 3 and 4 numbers of wing walls. Generally the abutments are constructed with brick masonry or stone masonry, and above this abutment you will have the slab. If you see the half longitudinal section on CVEF, you can see the curve. The curve is nothing but the raised side work, and the main purpose of the curve is to prevent the traffic from skidding off the carriageway. These are the parapets, and this is the coping of parapet. Students, look at the plan, and here you can see 70 centimeter or 700 mm is the width of the trench. Okay, here it is the width of the trench, and we are having an offset of 15 centimeter or 150 mm. Okay, so from here we can find out the width of the wing wall. How can we find this width of the wing wall? See, the total width of the trench is 70 centimeter or 700 mm minus, there is offset present on either side of this trench. So here this side 150 mm, here this side 150 mm. So 2 into 150 mm, which is equals to 400 mm. So the width of the wing wall is 400 mm. And from the plan, it is clear that the 1.2 meter is the length of the wing wall, or 1200 mm is the length of the wing wall. Okay, and the dashed line here you can see the dashed line. These are the plan of wing wall. These are the plan here. These are the plan of wing wall and abutment and the cement concrete bed. Here 4 meter roadway is shown with arrows. This is the distance between the curves. So now let's look at the sectional elevation. Here we are having the sectional elevation, and you can see the width of foundation for abutment is 70 centimeter or 700 mm, and over the cement concrete bed we are having the abutment. Here, see, it is the cement concrete bed, and over here we are having the abutment being constructed. And below ground level you have a depth of 300 mm plus 300 mm equals to 600 mm depth of foundation. In this sectional elevation you can also see the depth of the slab. Here the depth of the slab is 20 cm or 200 mm. Below the ground level and between the abutment, the portion is provided with stone pitching, and this stone pitching avoids the scouring due to flow of water. Okay, so with this background knowledge, we shall start step by step the detailed estimate of RCC slab culvert. For the detailed estimate of RCC slab culvert, we have to prepare a table like shown in the screen. The table will consist of item number, particulars of items of work, the number of items, and length, breadth and height or depth in meter, then quantity and explanatory notes if there are any. Okay, so if you are good at understanding the plan and sectional elevation, then definitely you will score very good mark in estimation. So this table will show you the details of measurement and calculation of quantities. So here in the RCC slab culvert, the first item is earthwork in excavation. This excavation work in foundation is done for abutments and wing wall. See this plan, you can see clearly there are two number of abutments. This is number 1 abutment, this is number 2 abutment, and 4 number of wing walls. 1, 2, 3 and 4 number of wing walls. So the excavation work for abutment is done from here, this point, to this point. As you can see in the figure, from this point to this point, the length is given 4.8 meter, and there is an offset of 15 centimeter or 0.15 meter on either side. Here 0.15 meter of offset and here 0.15 meter of offset. So the total length is 4.8 plus 0.15 plus 0.15 equals to 0.15 plus 0.15 equals to 5.1 meter. So, and the breadth of the abutment for which excavation work is done is from here to here, and this breadth is given as 70 centimeter, which is equals to 0.7 meter. And what is the depth of the abutment for which excavation work is done? For this you have to see the elevation. Here you can see below the ground level, from this point to this point, the total excavation work is to be done. So this is 30 centimeter plus 30 centimeter equals to 60 centimeter or 0.6 meter. In the similar manner, we have to find out the length, breadth and height of the wing wall for which the excavation work is to be done. So the length of the wing wall, from the plan it is clear, 1.2 meter, and the breadth of the wing wall is also clearly mentioned in the plan as 70 centimeter or 0.7 meter, and the height or the depth for which the excavation work is done for wing wall is from this point to this point, so that is 30 centimeter plus 30 centimeter equals to 60 centimeter or 0.6 meter. So let's quickly fill the table. And the number of abutments first is 2 number of abutments. The length for which excavation work is done is 5.1 meter, and the breadth for which the excavation work is done is 0.7 meter, and the depth is 0.6 meter. Then wing wall, the number of wing walls are 4, and the length of wing wall is 1.2 meter, and the breadth of the wing wall is 0.7 meter, and the depth of wing wall for which excavation work is done is 0.6 meter. Now we will calculate the quantity. So for calculating the quantity, we have to multiply the length, breadth and height or depth with the number of items. So 5.1 multiplied with 0.7 multiplied with 0.6 multiplied with number of items, that is 2, equals to 4.28 cubic meter. Then for wing walls, we have to again calculate the quantity. So 1.2 meter multiplied with 0.7 meter multiplied with 0.6 meter multiplied with the number of wing walls, that is 4, equals to 2.016. So I will round it to 2.02 cubic meter. So the total quantity will be, we have to add 4.28 with 2.02. So this will be 6.3 cubic meter. So the next item is cement concrete in 1:3:6 proportion in the foundation with stone ballast. So cement concrete work is done again in abutment and wing walls. So we have to find out the length, breadth and height or depth of the abutment and wing wall where cement concrete work is to be done. So let's see the plan again. So the cement concrete work is done for abutment from this point to this point. So the length of the abutment will be 4.8 plus 0.15 plus 0.15 equals to 5.1 meter, and the breadth for which cement concrete work is to be done is 70 centimeter or 0.7 meter, and the depth of the abutment for which cement concrete work is done is from here to here. The cement concrete work is done from this level to this level. So this is 30 centimeter or 0.3 meter. Similarly, for wing walls, the cement concrete work is done from this point to this point. So the length is 1.2 meter and the breadth of wing wall is 70 centimeter or 0.7 meter for which the cement concrete work is to be done, and the depth of wing wall for which cement concrete work is done is from here to here, which is 30 centimeter or 0.3 meter. So let's quickly fill this data. Number of abutments are 2, length is 5.1 meter, breadth is 0.7 meter and depth is 0.3 meter. Number of wing walls are 4 and length is 1.2 meter and breadth is 0.7 meter and depth is 0.3 meter. Now we will quickly calculate the quantity. First we will calculate for abutment. So 5.1 multiplied with 0.7 multiplied with 0.3 multiplied with number of abutment, that is 2, equals to 2.142. So 2.14 cubic meter. Then next for wing walls we will calculate it. 1.2 multiplied with 0.7 multiplied with
0.3 multiplied with number of wing walls, that is 4, so which is equals to 1.008 cubic meter, and I will round it to 1.01. So the total quantity will be 2.14 plus 1.01, which is equals to 3.15 cubic meter. After cement concrete work, the next item is first class brickwork in 1:4 proportion cement mortar, which is to be carried out in abutment, wing wall and parapets. Okay. If you see the three-dimensional view of RCC slab culvert, you can clearly see the abutment. This portion, this is abutment, and in this figure you can see the wing walls. This is one wing wall, number 2 wing wall, number 3 wing wall, and the 4th number wing wall is hidden somewhere here. And you can see the parapet clearly. This is one parapet and this is another parapet. So there are 2 number of parapets. One is above the slab and up to the curb, and another parapet excluding the coping. This is the coping of parapet. So this is another parapet which is above the curb from this portion to this portion. Okay, so the brickwork is to be done in the abutment and in the wing wall and in the parapet and in the coping of parapet. So we have to calculate the quantities of first class brickwork. Okay, so let's see the figure. So the length of abutment for which the brickwork is to be done is from this point to this point. So this is 4.8 meter. And what is the breadth of the abutment for which the brickwork is to be done? This is 40 centimeter. So brickwork is done from this point to this point. So this is 40 centimeter or 0.4 meter. And what is the height of the abutment for which brickwork is done? From road level to ground level, the height is given 1.3 meter, and there is a height. So we have to deduct 10 centimeter from 1.3 meter. So it will be 1.2 meter. So 1.2 meter plus the abutment below the ground level here. This is 0.3 meter. So 1.2 meter plus 0.3 meter. It will be 1.5 meter. Okay, so let's quickly fill the table. The number of abutments 2, length is 4.8 meter for which brickwork is to be done, and the breadth for which brickwork is to be done is 4.4 meter or 40 centimeter, and height for which brickwork is done is 1.5 meter. And next one is wing wall. The length of the wing wall for which brickwork is done is 1.2 meter. Here see, from this point to this point the brickwork is done for wing wall, and the breadth of wing wall where brickwork is done is 40 centimeter. From the plan it is clearly visible that the breadth of wing wall for which brickwork is done is 40 centimeter or 0.4 meter, and the height is 1.5 meter. In the same manner that I have calculated the height for abutment. So let's fill the table. Number of wing wall is 4. The length is 1.2 meter. The breadth is 0.4 meter. And the height is 1.5 meter. And the number of parapets are 2. And the parapet up to the curb, which is here you can see, this is the first parapet which is above the RCC slab, and up to the curb it is having a breadth of 40 centimeter or 0.4 meter, and it is having a depth of, see, from this point to this point is 20 centimeter, and the curve is of 10 centimeter height. So 20 centimeter plus 10 centimeter equals to 30 centimeter or 0.3 meter. And the length of the parapet, we can calculate, we can observe the length of the parapet from the half sectional elevation. Here you can see the total length of coping is 4.9 meter, but there is projection on either side. Here there is a projection and here there is the projection of 10 centimeter. So we have to deduct this 10 centimeter or 0.1 meter from the entire length of coping to get the length of the parapet. So 4.9 meter minus 4.9 meter minus 0.1 meter minus 0.1 meter of projection equals to 4.7 meter, which is nothing but the length of the parapet. Okay, so let's quickly fill the table. Number of parapet up to curve is 2, length is 4.7 meter, breadth is 0.4 meter or 40 centimeter, and the height of the parapet is 0.3 meter. So next one is parapet above the curve. So the parapet above and excluding the coping is from this point to this point, and from this point to coping the entire height is given as 60 centimeter. So if we exclude the coping, which is having a height of 10 centimeter, so we can get the height of the curve above the the height of the parapet above the curve from this point to this point as 50 centimeter, because from this point to this point the entire height is 60 centimeter. If we minus the height if we deduct the height of coping, that is 10 centimeter from 60 centimeter, we will get the height of the parapet 50 centimeter, and the breadth of parapet here is 30 centimeter or 0.3 meter, and the length of the parapet will be 4.7 meter. After deducting the width of projection from the total length of coping, that is 4.9 minus 0.1 minus 0.1 equals to 4.7 meter. So let's fill the table. Number of parapets above the curve is 2, length is 4.7 meter, breadth is 0.3 meter, and the height is 0.5 meter. And next the brickwork is done is for parapet coping. So the number of copings are 2. The length of the coping is 4.9 meter. I have already discussed it, so I am writing it directly. And the breadth of the coping see, the breadth of the coping is from here to here. So from this point to this point, we know the breadth is 30 centimeter and there is a projection of 10 centimeter. So 30 plus 10 centimeter equals to 40 centimeters. So 0.4 meter is the breadth of the coping. And what is the height of the coping? It is 10 centimeter. So here it is 0.4 meter and the height is 0.1 meter. And if we calculate these quantities, I have already calculated these quantities, so I am writing it directly. You can use your calculator to find out these quantities. It is 5.76 cubic meter. This is 2.88 cubic meter. This is 1.13 cubic meter. And this is 1.41 cubic meter. This is 0.39 cubic meter, and the sum of 5.76 plus 2.88, 1.13, 1.41 and 0.39 is 11.11 11.57 cubic meter. 11.57 cubic meter. Now we have to deduct the bearing of RCC slab in the abutment. See why we have to deduct this, because while calculating the quantity for earthwork, we have taken the entire width of abutment here. This is 40 centimeter, but in this portion where there is slab is present, no brickwork is done in this 30 centimeter breadth, and the height of the slab is 20 centimeters. So in this portion no brickwork is done. So we have taken this quantity on either side to find out the quantity of brickwork. So but in practical case there is no brickwork is done in this portion and in this portion. So we have to deduct the bearing of RCC slab in abutment in these two portions. So the breadth in this portion is 30 centimeter and the height is 20 centimeter. And what is the length of RCC slab? It is 4.8 meter. The RCC slab will be having a length of 4.8 meter from this to this point. Okay, so the number of bearing of slab in abutment is 2 and the length is 4.8 meter. The width is 0.3 meter and the height is 0.2 meter, and I have already calculated the quantity. It is 0.57 cubic meter. So the net total will be 11.57 cubic meter minus 0.57 cubic meter, which is equals to 11 cubic meter. And the next item is RCC work in 1:2:4 proportion in slab, excluding the steel and its bending, but it includes the centering, suturing and binding steel. Okay, so in order to find out this quantity, we have to find out the length of the RCC slab. I have already shown you the length of the RCC slab, which is 4.8 meter, and we have to find out the width of the RCC slab. See, from this point to this point the width is given as 1.5 meter, and here you can see the slab which is embedded in the abutment having a width of 30 centimeter on either side. Here this side 30 centimeter, here this side 30 centimeter. So 1.5 plus 0.3 plus 0.3 meter is equals to 2.1 meter. So the total width of the RCC slab will be 1.5 plus 0.3 plus 0.3 equals to 2.1 meter. And what is the depth of the RCC slab? It is 20 centimeter. Clear? So it is 4.8 and it is 2.1 meter and it is 0.2 meter. And the number of RCC slab, only one number of slab is provided, so it is 1, and the quantity is, I have already calculated it is 2.016 cubic meter. And here there is no deduction for volume of steel is considered. So in this manner we will calculate the quantities for the RCC slab culvert. So in today's lecture video we have discussed the definition of culvert, types of culvert, the three-dimensional construction sequence of RCC slab culvert, the differences between a bridge and a culvert, the different parts of a culvert, and we have discussed in detail the estimation for 4 items. In the next lecture video we will discuss about the estimation part of the remaining items. So if you have got any doubts you can ask me. So thank you students.